How strong of an electric field is needed to balance the force of gravity on a titanium nucleus? In this diagram, you can see the titanium nucleus hovering over this positively charged plate. And in green, the force of gravity pushing down, and in red, the force of the electric field pushing up. The two equations we will need to use are Fg is equal to mg and Fe is equal to QE. Because the two forces are balanced, we know that the force of gravity is equal to the force of the electric field. The first thing that we will look for is the mass of the titanium nucleus. To find the mass, you'll take the atomic mass, which is 48, multiply that by the mass of a proton or neutron, which is 1.67 times 10 to the negative 27. And that will give you 8.02 times 10 to the negative 26 kilograms for the mass of the nucleus. Next, you can use that mass to find the force of gravity. So mass, which is 8.02 times 10 to the negative 26, times the acceleration of gravity, which is 9.81, and that will give you 7.87 times 10 to the negative 27 newtons going down. Since the force of gravity is equal to the force of the electric field, we can use Fe is equal to QE to solve for E. But before that, we need to look for charge. To find the charge, you take the atomic number, which is 22, multiply that by the charge of a proton, which is 1.6 times 10 to the negative 19. So the charge is 3.52 times 10 to the negative 18 coulombs. Now that we know the force of the electric field as well as the charge, we can solve for E. Using the same formula, you input the force of the electric field as well as the charge, and rearrange the formula to solve for E. So 7.87 times 10 to the negative 25 over 3.52 times 10 to the negative 18 gives you electric field, which is 2.24 times 10 to the negative 7 newtons per coulomb going up.